In this video, I'm going to discuss a certain interesting function called the group number function. The group number function gives the number of groups of order n up to isomorphism. It is written as GNU n. So let's give some examples of the values of the group number function. So the groups of order 1, there's just the trivial group, so there's one such group. Now for P of prime, the groups of prime order is also 1, it's just the cyclic group of that order. I've made a video proving this. The groups of order P squared, there's 2 of those, it's the cyclic group of order P squared, and this direct product, groups of order 2p, there's 2 of those as well. It's the cyclic group and the dihedral group. It turns out, and I haven't made, as of yet, made this video, but I probably will at some point, the groups of order p cubed, there's 5 of them. In particular, for p equals 2, the group number function of 8 is 5, because the groups are C8, D8, Q8, the quaternion group, C4 cross C2, and C2 cross C2 cross C2, which is also known as the elementary abelian group of order 8. Other results that I may eventually make videos on as well, the groups of order 4 times a prime. Turns out that there are 5 of those when 4 divides the prime minus 1, and 4 of them otherwise. If we continue to look at prime powers, we can get even more complicated results. So it turns out that for p to the 4, the classification gets a bit messy as well. So there's 14 for p equals 2, that is groups of order 16, and the rest are all 15. Now, we also know formulas for the exact values of the group number function of p to the 5, p to the 6, and p to the 7, but they are very messy. In particular, they are polynomials in P on various residue classes. It is a conjecture called Higman's PORC, meaning polynomial on residue classes, that this is the case for GNU P to the n for all n. What are some nice bounds for GNU n? N is just any number now. So one observation we can make is that the group number function must be less than or equal to n to the n squared. Why is that the case? Well, observe that the number of binary functions from a set of size n to itself, well, there's n squared pairs of things, and then you have n choices for where it goes. So this must be an upper bound. This is quite a bad upper bound. So for example, it gives us GNU of 8 is equal to 8 to the 64. It's less than or equal to 8 to the 64 even, which is indeed true, but it's just 5, so that's not a very good bound. Elementary methods can make this bound better, this bound slightly better. Indeed, we can show that the group number function is less than or equal to n factorial to the power of log base 2 of n using elementary group theory. I may make a video on this particular bound at some point because it is quite a nice proof. But that's still quite a terrible bound. With the n factorial, that obviously goes quite quickly, and then we're taking a power of that. Back to p groups, Higman demonstrated the bound. The group number function of order p to the n is certainly greater than p to the 2 over 27 n squared n minus 6, and it's less than p to the 2/15 plus epsilon n cubed for a certain sequence epsilon n that tends to 0 as n tends to infinity. So these are significantly stronger bounds. These have since been improved on somewhat. And this, I believe, was in the 1960s where these bounds are proved, I mean. The smallest value of GNU, which is unknown, is GNU 2048. Well, why is that? Well, if you have a look at it, 2048, that's 2 to the power of 11. And it turns out that groups of a power of 2, there's just loads of them, and it gets pretty difficult to classify them. We have the exact value of 1024, which is 2 to the 10. It is in fact equal to 49487367289. This will just take a lot of computing power to figure out stuff like this. Other small unknown values include on 3072, 4096. Those are the second and third smallest respectively, which are 2 to the 10 times 3 and 2 to the 12. Other unknown facts. It is unknown whether GNU is surjective. That is, for all natural numbers m, does there exist n in n with GNU n equal to m? Also, it is unknown whether there is a fixed point of GNU other than GNU 1 equals 1. Where is GNU n equal to 1? That is, what numbers only have the cyclic group as their group. Well, certainly n is prime works, also n is 1 works, but actually there's a more general and complete classification. It's if and only if the greatest common divisor of n and phi n is equal to 1, where phi is Euler-Totient function. As an example, GNU 15 is equal to 1 and 15 is composite, but the Euler-Totient function of 15 is equal to 8, which is certainly coprime to 15. In a paper, Conway, Dietrich, and O'Brien give a classification of where GNU n is equal to 2, 3, and 4. I'll link that paper in the description, as well as providing other results and conjectures on the group number function.